So let me start to solve, guys. The question is, if the value of the definite integral of coordinates of 1 by root of 1 minus x square times of coordinates of x by root of 1 minus x square to the power of root x, then of whole dx is given as pi square times of root of a minus root b by root c, where your a comma b comma c belongs to your natural numbers in their lowest form, then find out the value of sum of your a, b and c. So people, this question needs lots of properties and this is not an easy one. It's a very good question. It's a very good question. So first, how I'm going to solve this question is, you need every kind of substitution technique, every kind of property which you guys learn in your integration. If you're pakka in integration, you guys just can solve this one. So now what I'm going to do is just observe the integral given in the question. There is some integral given in the LHS and there is some expression given in the RHS. From that we have to arrive at the value of a and b and c, then we can find the sum. So now what I'm going to do here is, we know this is the integral we are having. Let me take this integral as I. So now for this integral, I'm going to use your famous property, that is nothing but your King's rule, in order to simplify it further. So what does your King's rule say? Your King's rule say that integral of any function f of x dx when the limits are from a to b. Using King's rule, this definite integral can be written as integral of f of a plus b minus x of dx from a to b. This is what your King's rule says, right? Just need to exchange or interchange the value of x as sum of your lower limit and upper limit minus the x, minus the inside value. Okay, so this is what your King's rule says. So now using King's rule, what I can do here is, your f of a plus b minus x of dx will be nothing but, one second, your f of a plus b minus x of dx will be nothing but f of minus 1 plus 1 minus x. That will be f of 0 minus x. F of 0 minus x is f of minus x. So here the same integral I can write it as using King's rule. So this same I can write it as I is equal to integral of f of a plus b minus x. A plus b minus x means f of lower limit plus upper limit minus x. So that is your f of 0 minus x, which is nothing but your f of minus x. To find out the value of f of minus x, just replace your x as minus x. Therefore, get it as cot inverse of 1 by root of 1 minus x whole square will be x square only. Then times of cot inverse of x we are having. So replace x as minus x, that will be minus x by root of one second, wait, root of 1 minus x square. Minus x whole square is x square only. X square times of mod of minus x plus x only. So this is something we guys will be left out. So I think it's correct, mod x. We can write the mod x itself. No problem, I guess. Yes, there's no problem. It's just write it as mod x. Okay, so this is something we will get when we use your King's rule. So now I'm sure that you guys will know what's the next step we are gonna proceed further. Of course, I'm sure about it because people, after King's rule, the integral which we got is this one. This is the simplified form, and now further I can't just simplify just like that because I can't use any kind of property. Therefore, you can just add up these two integral. I can add these two i's. So I plus I is 2i. Then your limits are from minus 1 to 1, same limits. Then if I need to add, just observe the inside function. Every value is same, but the only difference is this x is replaced by minus x. So I need to add this expression with this expression. Here, this particular term is common. Therefore, when I take this as common, I'll get as cot inverse of 1 by root of 1 minus x square. Correct or not? When I take this common, this is something I will be left out. Then, this plus this term. Correct or not? Because people, I'm adding out these two expressions on the whole. I'm adding out these two expressions on the whole. So therefore, when I take this particular term common, then I will do it as this plus this in this particular bracket. So when I do like that, this will be cot inverse of x by root of 1 minus x square to the power of mod x, then plus of this particular term. So I'm having cot of minus of this particular expression. So using your property, using a formula of your inverse trigonometric function, can't I say that your cot inverse of, guys, this is cot inverse. If I say this cot, sorry for that, it's cot inverse. So cot inverse of theta can be written as pi minus cot inverse of theta. I mean cot inverse of minus theta can be written as pi minus cot inverse of theta. Okay, so cot inverse of any negative value, I can write it as pi minus cot inverse of theta. People, sorry for writing as theta, because theta we use it for angles, right? Here it should be a value. So let me take it as cot inverse of minus x itself. So cot inverse of minus x can be written as pi minus cot inverse of x. This is one property of your inverse trigonometric function. So cot inverse of any negative value can be written as pi minus of cot inverse of that particular value. Okay, so using this particular formula, can't I write the same expression as plus of pi minus cot inverse of x by root of 1 minus x square, right? Then to the power of mod x. Can't I write like this? Just think carefully and say, people, if I need to add these two integral, I'm just taking out this particular term common, then you just need to add these two terms just like that. Then I'll be getting this term. I'm just writing this term as pi minus of this particular term. Therefore, this and this will get cancelled. Correct or not? Dx, there should be a dx over here. Okay, if I forget dx, don't worry. You guys should know that that's dx over there. Okay, so this term will get cancelled just by using this particular formula. Why I am using this formula? Because I am having minus of this particular expression. Because minus is in the denominator. Okay, so now this particular expression we have got now. So next, I'll wrap these things, guys. Then what I'm gonna do is, just listen to me very carefully, observe each and every step. So something we got, so just write out the integral we have got now. So 2y is equal to integral of minus 1 to 1 times of cot inverse of 1 by root of 1 minus x square. This is something we have now. Then pi is left out, right? I'll take this pi outside. So this is something we guys are left out with, because these two terms are cancelled, so pi is left out. So pi is as a constant, and it is outside. Okay, people. So this is something we are left out with. So now what the next step I'm gonna do over here is, let's just listen to me very carefully. So this 2y is equal to pi times of cot inverse of 1 by root of 1 minus x square. So this 2y, can't I write this 2y as 2y is equal to pi times of integral of minus 1 to 1, then tan inverse of root of 1 minus x square. Can't I write like this? It's very simple. Cot is 1 by something, I can just tan of the same thing. Cot is 1 by x is tan of x. Basic property of your, I can say it's a property, it's a basic thing that you guys are supposed to know in your inverse trigonometry function, ITF. So coordinates of 1 by something and it is tan of root of 1 minus x square. This is something I'm having now. Now people, I will ask you guys one thing. Here I am having 2I in the LHS and I am having the limits from minus 1 to 1 in the RHS. This shows that you can use one property of your definite integral. There is nothing but your integral of f of x dx. And the limits are from minus a to plus a. This can be written as the value of this integral will be 0 if your f of x is an odd function. And this same integral can be written as 2 times of integral of f of x dx, but the limits will be from 0 to a. Minus a to plus a will integrate as 0 to a if your f of x is an even function. If it's even, this format. If it's odd, it will be 0. Now tell me whether this particular function that stands the root of 1 minus x square even or odd. Of course it's even, because the term that is having your x is x square. So minus x the whole square plus x square only. So f of minus x is giving the same value of f of x. That means an even function. Therefore use this particular second formula. So this 2 I can write it as 2 times of integral of fx. So 2 times of integral means 2 pi times of integral of root of, then the limits will be from 0 to 1. Okay, so this and this will get cancelled. Therefore your I will be nothing but pi times of 0 to 1. This is something we guys will be left out. Okay people, just by using the basic property of your definite integral. So this is the final integral. We got to know that. Now people, think what I can do. So now what I'm gonna do is I'm gonna use your bypass rule. I'm gonna use your bypass. So what I can do is, 1 second, wait. Here it will be 1 and I forgot to put the dx. So dx. So now I'm gonna use your bypass. I know you guys will ask me one question. We know that for bypass there must be 2 functions, but here there is only one function, that is tan of root of 1 minus x square. So where is another function? People, this tan of root of 1 minus x square can be written as times of 1. Then becomes a 2 functions, because one is a function, it's an algebraic function, right? When we come to the part of Eilert rule, so that we can say this one as algebraic function. Guys, this is a simple method, everybody knows, but just I'm explaining for those who thinks why I'm writing your 1 as a separate function. Okay, so I can write this particular tan of root of 1 minus x square, tan of root of 1 minus x square times of 1. Like I can write this 2 functions. Now, which function will take as first function? We know that one is tan of root of 1 x square and another is 1. Which will I take as first function, second function? Using your Eilert rule. We know that your tan of root of 1 minus x square is your inverse function. And that 1 is your algebraic function. So in Eilert rule, algebraic function comes, inverse function comes ahead of your algebraic function. Inverse function comes ahead of your algebraic function. Therefore, take your tan inverse of root of 1 minus x first function and 1 as your second function, because inverse function is before your algebraic function or ahead your algebraic function in your Eilert rule. So therefore, using a bypass, this I can write as pi times of. Listen to me very carefully, because this is very important. Using a bypass, I can write it as first function. So first function is tan of root of 1 minus x square times of integral of your second function, that is integral of 1 dx, and the limits will be from 0 to 1. Okay, wait. Then minus of derivative of your first function. Derivative of first function is d by dx of tans of root of 1 minus x square times of integral of your second function. What is integral of your second function, people? So integral second function, integral of 1 dx. Then we have to put a whole integral, then a dx on a whole. Okay, this is something we will be left out with. So now let me solve it further. So here it will be 0 to 1, 0 to 1. So limits, don't forget to put the limits. So first function into integral of a second function. Okay, first function integral of a second function minus of derivative of first function into integral of a second function. Then put the integral on a whole and the limit should be same, just like that. Okay, so this is what we guys are supposed to do. So this I will write it. I will write it the final answer. Okay, so I will be nothing but pi times of, so tans of root of 1 minus x square, then times of integral of dx is x, right? So into x, and from 0 to 1, then minus of integral, this integral I am writing, this whole integral from 0 to 1 times of d by dx of tans of root of 1 minus x square. How will you find the difference of tans of root of 1 minus x square? So we know that d by dx of tans of x is 1 by 1 plus x square. Correct or not? 1 by 1 plus x square. That means 1 by 1 plus the inside function square. So I can write it as 1 by 1 plus the inside function square is root of 1 minus x square, the whole square is 1 minus x square. Okay, and now along with that write differentiation of 1 minus x square is minus 2x. Okay, minus 2x by 1 by 2, so 2 times of root of 1 minus x square. I think this is what you guys will be getting. Okay, then integral of 1 dx from 0 to 1. So this will be nothing but what? This will be nothing but x. Okay, okay, so this will be left out. So am I finding d by dx of tans of root of x square? It's very simple. You guys learn in differentiation, just differentiating with respect to the outer function. This looks like a composite function, right? Do the same concept over here. This is something you guys will be getting. This is times of x. Okay, people. So now the next step, one second. The next step I'm gonna do is, listen to me very carefully. So here I'm having pi times of, here also should pi, right? Sorry, I forgot this. Should be pi, because pi I put it on a whole. So now we know that of course this particular term is 0. Why it's 0? Because when I put 1, I'll get tans of 1 minus 1, that is your 0. So tans of 0, infinity, tans of 0, then the whole value will be 0. Because when you just put the limits, this is something you guys will be getting. So when you put the lower limit, it will be 0 times x is 0, 0, so 0 times, so whole 0. Therefore this particular term is 0. So don't care about this particular expression. Okay, so I will get I is equal to this particular expression. So this minus cancel, this two cancel. So therefore I think we'll be left out with I is equal to pi times of integral of 0 to 1, then x into x is x square by 2 minus x square times of root of 1 minus x square. This is something you guys will be left out when you just solve this. Okay, so times of dx from 0 to 1. So this is what we will get it as I. The next step I'm gonna do is I'm gonna take your x is equal to sine theta. When you take your x is equal to sine theta, then dx will be nothing but difference of sine theta is cos theta times of d theta. So people, Actually, you may ask why I'm taking x is equal to sine theta. Just observe the expression. I'm having x square, root of 1 minus x square. So 1 minus x square is 1 minus sin square theta, which is cos square theta. So root of cos square theta is cos theta. I'm getting the value like that. And basically, in the chapters like the functions and your integration, you will learn the substitution methods. For what value you should take what substitution. Like for a plus x square, what substitution. A minus x square, what substitution. Root of a minus x square, what substitution. Those things you will learn. And that is must important for your JE point of view. So that's what I'm using here. So when take x sine theta, how will I get this I? So it's a very big question, guys. Then I can be written as pi times of integral of x square is sin square theta by 2 minus x square is 2 minus sin square theta. Okay, well, I will solve it fast. So root of 1 minus x square is root of 1 minus sin square is root of cos square theta is cos theta. Then times of dx is cos theta d theta. So this cos theta cancel, and what will be your limits? So this 0 and 1 take up on the value of x. So we need to put the value of theta over here. So sines of 0 is 0. Sines of 1 is pi by 2. I mean, you will get 0 if you'll get the value of x is 0 if your theta is 0, and you'll get the value of x is 1 if your theta is pi by 2. That's all. That's a methodology of solving your limits when we're using a substitution. Okay, so next step is what I'm gonna do is, can't I write the same expression as minus pi times of minus sin square theta? Actually, I'll say the reason for, actually you guys will know the reason for doing this. I'm just writing it as minus times of minus. In here it will be the same expression, but I'm doing this for a further calculation. Okay, I'm writing it as minus pi times of integral of minus sin square theta. Okay, people. So then what I'm gonna do is, so in your numerator I'm gonna add 2 and subtract 2. In your numerator I'm gonna add 2 and subtract your 2. This is what I'm gonna do over here. And this 2 minus sin square I will put a bracket. So I'm gonna add 2 and subtract 2. Initially I multiplied minus 1 in the numerator. Anyway it will nullify and give us plus. So then I added your 2 and subtracted 2 in the numerator, and I put the bracket on your 2 minus sin square theta, because I'm gonna split the term just like that. Actually this can be done as minus pi times of integral of 0 to pi by 2, 2 minus sin square theta minus 2 by 2 minus sin square theta. They take this 2 minus sin square theta as a separate term and this 2 as a separate term and split it with the denominator. So therefore this can be written as 2 minus sin square theta by 2 minus sin square theta is 1 minus of 2 by 2 minus sin square theta, then the whole d theta. Okay. The next step, just listen to me very carefully. I'm having minus over here now. So take minus common from the inside function. Therefore I'll be getting it as 2 by minus 1. So when I take the minus common, this will become plus. Okay, this will become plus. So what I did is, I'm having 1 minus 2 by 2 minus sin square theta. I took minus common out here, therefore inside function will become like that, and the minus over here will become plus, because minus times of minus is plus. So this is what we got over here. Okay, so now just solve it, and it's an easy one, pretty easy question from now. So I can write this d theta. So this I can write it as, just separate it out. So pi times of integral of 2 by 2 minus sin square theta. Okay, there's more steps hereafter. Then minus of, take this pi to the 1. So minus of pi times of integral of d theta from 0 to pi by 2. Correct or not? Pi times of integral theta from 0 to pi by 2. So just put the value, d theta integral is theta. So theta pi by 2 value. So you'll get pi by 2 times of pi. That is pi square by 2. Guys, these things are very easy. So I'm solving fastly. Pi square by 2. So now this integral is something we guys are supposed to take care. So I is equal to this particular integral. So we just care about it. What the step I'm going to do is I'm going to divide your cos square theta on both numerator and denominator in this particular integral. Therefore I'll get it as I is equal to pi times of integral of 0 to pi by 2. Then when you divide your cos square theta on numerator, I'll get it as 2 by cos square theta, that is 2 secant square theta. Okay, then divided by 2 secant square theta, then minus of sin square theta by cos square theta is tan square theta. Then d theta, I forgot to put d theta over here, and d theta minus of pi by 2. This pi by 2 is a separate value. It's not included in the integral. Don't forget that. Okay. Next step, what you're gonna do is, guys, I just did a simple thing. I divided the cos square theta on both numerator and denominator. Okay. The next step is, listen to me very carefully. I is equal to pi times of 0 to pi by 2 times of 2 by 2 times of secant square theta minus tan square theta. So this secant square theta minus 2 secant square theta minus tan square theta can write the secant square theta as 1 plus tan square theta, basic Pythagorean identity of your trigonometry, then minus of tan square theta, then minus pi square by 2. Okay. So this all will be left out. I'm just writing a secant square theta as 1 plus tan square theta using a trigonometric Pythagorean identity. So this I can write it as, so after solving out I can write it as pi times of integral of 0 to pi by 2 then 2 secant square theta by 2 times of 1 plus tan square theta is 2 plus 2 tan square theta minus tan square theta. 2 into 1, 2 plus 2 tan square theta minus tan square theta will be 2 plus tan square theta. Okay, people. So now what I'm going to do is use a substitution. So it will be d theta over here. Then minus pi square by 2. So I will rub these things. Minus pi square by 2. So again I'm going to use a substitution, which is an important substitution for this question on the final touch. So what substitution I'm going to use is, I'm going to take your, it's very simple. From this I can observe that I can take your tan theta is equal to some t, then dt will be nothing but secant square theta of d theta. So when you do the substitution over here, let it as I is equal to pi times of 0 to pi by 2 2 secant square d theta. Secant square theta d theta is dt. So 2 secant square theta d theta I can write as dt by 2. So dt over here and 2 over here. Then 2 plus tan square theta is 2 plus t square. So this 2 I can write as 2 to the whole square plus a t square. That's all. Almost, it's not like almost, we have done with it. Completely we have done with it. Okay. So actually what I did is very simple, guys. For this particular integral, here it will be minus pi by 2 the whole, not whole square, sorry. It will be pi square by 2. Okay. So this is all it. So this is the integral we are having. That is minus of pi square by 2. This particular integral minus pi square by 2. What I did is, for this particular integral, I took your tan theta as t. By observing itself, you guys must come to a conclusion about substitution. So tan theta is equal to t, then your secant square theta of d theta will be dt. So when I put the substitution of this integral, your 2 secant square theta of d theta can be written as dt by 2. So dt by 2 I took it outside, therefore it will be pi by 2. Along with pi, I multiply 1 by 2. Then divided by 2, I wrote it as 2 to the whole square. Not to use your standard integral formula that a square plus s square. In the denominator, if you have a square plus s square, there's a separate formula, right? For that one, I wrote your 2 as root to the whole square. Then plus of tan square theta is t square, as your tan theta is t. Then minus of pi square by 2. Now I will wrap this. The next thing is, and people, the limits will not be same, right? I wrote 0 to pi by 2. So for theta is equal to 0, your t value will be 0 only. For theta pi by 2, your t value will be infinity. Okay. So initially we have limits from 0 to pi by 2. So for theta is equal to 0, your t value will be 0 for your lower limit. For theta is equal to pi by 2, your t value will be infinity for your upper limit. So then it's very easy. So I is equal to pi by 2 times of integral of your dt by root 2 the whole square plus t square. So I'll write the formula over here. Integral of dx by a square plus x square is equal to 1 by a of tan inverse of x by a plus some constant. This is the formula. Okay, it's a very important formula, never ever forget that. So dt by root to the whole square plus t square. Always remember, a is your constant, x is the variable. Many people do the mistake, they just interchange the formulas. Actually what they do is, they will think x square minus a and a square minus x are the same. So that's why I'm saying a is a constant, x is a variable. So here a constant is root 2 and your variable is t. Therefore 1 by a will be 1 by root 2 times of tan inverse of x by a. X by a will be variable by root 2, t by root 2. Then from 0 to infinity minus of pi square by 2. So now I'll wrap this, guys. So now it's very easy peasy lemon squeezy, right? So let us I is equal to pi by 2 root 2 times of tans of t by root 2. So tans of t by root 2, tans of infinity will be what? Tans of infinity will be what? You guys think it's infinity? Yeah, 1 by root 2 times of 1 by root 2 times of pi by 2. Yes, pi by 2. So pi by 2 will get, right, because tans of t by root is tans of infinity by root 2 is tans of infinity. Tans of infinity is pi by 2 minus of tans of 0 is 0 only. So you don't need to write that. Then minus of pi square by 2 and get done with it. That's all, guys. So 2 root 2. What we can do over here? So actually what you can do over here is, I had 2 pi, right? 2 pi is 2 root 2. 2 root 2 I can write as 1 by 2 root 2 into root 2 by root 2. Root 2 by 2 into 4. Root 2 by 4. Okay. So I is equal to pi by 2. So 1 by root I will take. 1 by root 2 when a ratio is get as root 2 by 2, right? So root 2 by 2 into 2. Root 2 by 2 into 2. Another 2 over here. Then root 2 pi. Okay. Then minus of pi square by 2. So we need pi square common. Okay, it will be pi square over here, correct only. So take your pi square common. So therefore I will be equal to okay, pi square common root 2 by 8 then 1 by 2, right? Correct or not? I think it's right. And finally you can just do it, guys. I think it will be root 2 minus 1 by 2. So actually they didn't make a mistake. So root 2 minus 1. So root 2 common. So pi by 2. Oh, sorry. Initially, I